So here we are given question 1.1, solve for x. 1.1.1, x squared minus 8x plus 12 equals 0. You'll notice here that the highest power is your x squared term. Because your highest power is your x squared term, you're going to use either the quadratic formula or the cross method to solve this. I used the cross method here, and my factors ended up being x minus 6 into x minus 2 equals 0. I then took each bracket, made it equal to 0, and I solved for x. So x minus 6 equals 0, x equals 6, or x minus 2 equals 0, x equals 2. Okay, the next one here, 1.1.2. Solve for x again. You're given 2x squared plus 6x equals 10. Here they're asking you to solve this correct to 2 decimal places. Now again here, you'll notice that your x squared term is your highest power, the 2x squared term. So because x squared is your highest power, again this is a quadratic equation, so you can either use the cross method or the quadratic formula. But if you try to use the cross method here, it's not going to work out for you, so we'll use the quadratic formula. Your quadratic formula as per your data sheet is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. You need to determine your a, b, and c term from your equation in the second line there. Your a term is positive 2, your b term is positive 6, and your c term is negative 10. So where you see a in the formula, you substitute 2, where you see b, you substitute 6, and where you see c, you substitute negative 10. You'll end up with the quadratic formula of x equals negative into 6 plus minus the square root of 6 squared minus 4 into 2 into negative 10 all over 2 times 2. That plus minus there is really important when you're typing this in on your calculator. The first time you type this entire thing in, you'll use a positive there, and you'll get your answer x equals 1,19. The second time you type this in, you use a negative there instead, and you'll get your answer of x is equal to negative 4,19. Okay, again solve for x. 1.1.3, 3x to the power negative half is equal to 27. You'll notice here, when they want you to solve for x and you have x in just one term, you need to isolate the x, so to end up with x is equal to whatever everything else becomes. So your first term there, 3x to the power negative half, we'll start by getting rid of the coefficient. It's 3 times x to the power negative half. The opposite of multiplication is division, so we're going to divide both sides by 3. We'll end up with x is equal to negative half on the left hand side, and 27 divided by 3 is 9 on the right hand side. Now 9 can be written as an exponent of 3 to the power 2. And you have x to the power negative half is equal to 3 to the power 2 now. All you need to do now to solve for x is get rid of that power of a negative half. To get rid of this power, you need to raise the left hand side term to the power which is the inverse of negative half. The inverse of negative half is negative 2 over 1. So negative half times negative 2 over 1 will give us that 1 in the power for x that we need. If you're raising the left hand side to negative 2 over 1, you need to raise the right hand side to a negative 2 over 1 as well. So you'll end up with x is equal to 3 to the power of 2 times negative 2, which is negative 4. Now 3 to the power negative 4 is a negative exponent. You can write that as a positive exponent. It will become 1 over 3 to the power 4, which is 1 over 81. Okay, another solve for x here. We're given the square root of 3 minus x is equal to x minus 3. Now, when you're solving for x and you have the x inside a square root, you need to at some point get rid of that square root. So we'll start here, because we only have the square root on one side of the equation. We can square that square root to get rid of the square root. So if we need to square both sides now. The square root of a square cancels off, and we're left with 3 minus x on the left hand side. we need to square the right hand side as well. This is called squaring the binomial. You can open out this bracket here into x minus 3 times another x minus 3 and open it out using the FOIL method, but squaring the binomial is preferred here. So to square the binomial, you take the first term and multiply it by itself, so that becomes x times x, which is x squared. To get the second term, you multiply both terms. Negative 3 times x is negative 3x, and you double it, so you're going to get negative 6x there. Then the last term is negative 3 times negative 3, which is positive 9. Now we have 3 minus x is equal to x squared minus 6x plus 9. Take everything over to one side. You'll end up with 0 is equal to x squared minus 6x plus 9 plus x minus 3. Put your like terms together, you'll end up with 0 is equal to x squared minus 5x plus 6, and now you'll notice that that is a quadratic equation. You can solve that quadratic equation using the cross method or using the quadratic formula. I've used the cross method here, so I end up with 0 is equal to x minus 2 into x minus 3. Again, take each bracket, make it equal to 0, and solve for x. You'll end up with x is equal to 2 and x is equal to 3. Okay, another solve for x. X squared plus 3x is less than 0. This time they want you to solve for x in an inequality. So we start here by saying, by making sure that our 0 is on one side of the equation. So on the left hand side we have x squared plus 3x. We're going to try to factorize this. The first type of factorization you should look for is common factor. Here you can pull out a common factor between the two terms, which is x. So if you pull out x, you'll be left with a bracket of x plus 3 is less than 0. Take each part of that factorization and equate it to 0. So you'll end up with x is equal to 0 and, x plus 3 is equal to 0. Solve the other one for x, you'll end up with x is equal to negative 3. So our two critical values here are 0 and negative 3. This we are going to put on a number line. So there's our number line, we fill in negative 3 and 0 there. Those two critical values separate the number line into three parts: a left-hand side, a middle part, and a right-hand side of the number line. To get the signs that go on the top of the number line, you need to choose a part. So let's choose the middle part. If we're choosing the middle section of the number line, we're going to choose a number that's between negative 3 and 0. So any number, we can choose negative 2. We're going to take that number, negative 2, and substitute into the original equation. So negative 2 all squared plus 3 into negative 2 is going to give me on my calculator an answer of a negative answer, a negative 2 answer. So that's how my middle section of the number line becomes a negative sign on the top there. The signs that go on either side must alternate. So positives will go on either side, because if you read your number line from left to right, you can see now we have a positive, a negative, a positive. All signs are now alternating, which is how it's supposed to be. Go back to your original question. They asked you to solve for x where the equation is less than 0. If you think of any number that's less than 0, that would be a negative number, which means we go to our number line and we look for the section or sections on our number line where we see negative. So the only section that is a negative on the number line is that middle section. This means that our answer for x is in between two values. As I've written at the bottom, x is in between negative 3 and 0 there. Negative 3 is less than x, which is less than 0. Okay, here we've given 2x minus y all squared plus x minus 3 all squared is equal to 0. They want you here to solve for x and y. Usually these are simultaneous equations solved for x and y. In this case it's slightly different because they gave you both terms here that are squared and you're adding those terms. Any number squared is a positive. So in this case you'll be adding a positive number plus a positive number. But a positive number added to another positive number will not give you the 0 that they want there, because these are squared. Usually you need a positive number plus a negative number to give you a 0. But because these are squared, you will never get that negative. Any number squared will be a positive. The only way you're going to get something equal to 0 when you're adding them is if you have 0 plus 0. That's why we take each bracket and we make it equal to 0. We take the first bracket, 2x minus y, make it equal to 0, and x minus 3 also equals to 0. Solve x minus 3 equals to 0 first, you'll end up with x is equal to positive 3. Substitute that 3 into your other equation. You'll get 2 into 3 minus y equals 0, and solve for y. You end up with y is equal to a positive 6. The last question here for this algebra section is for which value of k will the equation 2x squared plus x equal k have no real roots? So no real roots is the same thing as unreal roots. You must remember that for unreal roots, delta is less than 0, where delta stands for b squared minus 4ac. So your equation that you need to work with is b squared minus 4ac is less than 0. You need to determine from the equation that's given your a, b, and c values to substitute into this equation. So we take everything over to one side. You'll end up with 2x squared plus x minus k is equal to 0. Your a term is a value in front of x squared, which is 2. Your b term is a value in front of x, which is 1. And your c term is your constant, which is negative k. Substitute those into your delta equation. You'll end up with 1 squared minus 4 into 2 into negative k less than 0. Open out your brackets. You'll end up with 1 plus 8k is less than 0. Solve for k. 8k is less than negative 1. Divide both sides by 8. You'll end up with k is less than negative 1 over 8.